Alright, types of reactions and chemical changes, part 2. We're going to take the balancing we did last week. We're going to build upon it. There's your joke for the day. It's chemical formula for banana. Banana 2. There you go. Alright, black background means you don't write it, right? This should be in your notes from last week.
What's the title again? Sorry.
Types of reactions.
Okay.
And changes. Okay. Last week, reactants. On the left side, you got the yield sign, then you got the product. So your chemical reaction is based off your reactants, then you produce your products. Alright? Law of conservation of mass says number of atoms in equals number of atoms out. Elements in equals elements out. Brushing off that rust from the 3-day weekend. You with us, Brian? You with us?
Yeah.
Alright. Did you get a haircut?
Yeah.
Look sharp.
No, that's fine.
Alright. New stuff. Okay. Tech was on last week's, but however, some of us struggle with balancing, so we're going to include this as well for this week's. Alright. When you look at a chemical reaction, there's two types of numbers. You have the subscripts, which tell you how many atoms are involved in that molecule. You cannot change that number. Water is always H2O. Regardless if it's ice or steam or liquid, water is always H2O. That means 2 atoms of hydrogen, 1 atom of oxygen. So, first piece of candy for today. What happens if I do change the number of hydrogens in oxygen and I do something like, oh, never mind, let's try this again. Let's see if this works. What if I do like H2O2? John, you know what that is?
You'd have to balance it on the other side.
No, I'm asking, what is H2O2? It's not water. We just changed what it was. Alex?
Oh,
Yeah.
it's dihydrogen dioxide. No.
Johnny?
Hydrogen peroxide.
Hydrogen peroxide, okay? By adding another oxygen molecule or another oxygen atom in there, we change the molecule and it turns into something completely different. So you cannot change this number because when you change that number, you change what the molecule is. Alright? Here, John? Uh-oh. Okay. However, what can we change? We can change the coefficients. Those are the numbers out front, and those tell you how many of that molecule you have. So if I were to have, let's draw this out. I got 1 water molecule, 2 water molecules, 3 water molecules. You can increase the number of molecules which you have. So all you have to do is multiply those numbers. So 3 times 2 would give you 6 hydrogens total. 3 times 1 would give you 3 oxygens in total. Okay? You can't change subscripts, you can change the coefficients. Good here? Alright, now let's get on to some new stuff. Lana looks enthralled. She's so excited to be here today. Alrighty. We're going to do types of chemical reactions. Please, 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 for everything that is good and right in this world, do not Google the types of chemical reactions because we're only doing 5 of them. There's about 20. Alright? At least 20 on the basic surface level. So don't do it. We're only going to do 5. So that being said, just go off your notes. Alright. So synthesis is one product being formed from 2 reactants. So A plus a B gets you AB. So we take a little bit of one thing, a little bit of another thing, shove them together. You have one product in the end. So the example here is if we take hydrogen and oxygen, mix them together with a lot of energy, do a chemical reaction, takes a lot of energy, but you can produce water. You can make one thing. Cool there? Your job, well, half your is looking at a chemical reaction. Tell me what kind of chemical reaction it is. The other half of it is the balance. However, we've upped our game up a little bit. Decomposition, all right, is the reverse of synthesis. So what we got here is we've got one thing, and we break that one thing into two separate things. All right. So we already said H2O2 is hydrogen peroxide. What do you use hydrogen peroxide for?
To heal cuts.
Not to heal them.
Clean 'em.
Disinfect them. All right. Lily, you ready? You want to shoot for it? When you pour hydrogen peroxide on your knee, what does it do? It fizzes, right? It bubbles. What gas is produced? It's in the equation right here. Right here. Hydrogen peroxide. When you pour it on your knee, it produces water and what's up? Oxygen. Absolutely. So, how do we know it's a chemical reaction? Absolutely. You got fizzing and bubbling, which are indicators of a chemical reaction. Ready?
Yep.
I'm going to try behind the back. Haven't done it already. She almost had the snag. That was a bad throw. If I was a little more to the left, it would have worked. Okay, how do we know this chemical reaction? Well, the best of what we can say is that when you pour hydrogen peroxide on your knee and it bubbles and fizzes, what happens? That molecule is rearranged in such a way where water runs off the side of your leg, and then it bubbles, and the oxygen is being produced, and that's why it bubbles. Where does it disinfect? There's a thing in here we haven't talked about, the energy of chemical bonds. So by releasing that energy, it tends to help disinfect it. Man, Brian's really struggling today. So is Elena. It's like extra sad or extra sleepy.
It's like a Monday, except it's not.
3-day weekend. She's gonna stay as late as we want on Friday, right? All right. At the end of class, I'll show it because I'm recording right now because somebody's gone third period. So at the end of class, I'm going to show a synthesis reaction. This is nylon. How does nylon work? So has anybody got any swish clothes on today? No. Maybe some of your shorts. So nylon. Most of those athletic clothing that goes swish is made out of nylon. How is nylon made? Nylon is made by taking two liquids, and when you combine them very slowly, you can actually pull out a nylon thread between the two. Super cool. At least I think it is. Decomposition reaction. This one is, you take, I think it's potassium permanganate, and you heat it up, and it creates a violent exothermic reaction, meaning it produces a lot of heat and it combusts into gas and a bunch of other crazy stuff. But I'm moving on to the other two types. This is where the majority of chemistry is at, are on these two types of chemical reactions. Call the first one here the home wrecker. Single replacement. One element replaces the other. C comes in and kicks B out. C was single before the reaction happened. Now B is single after the reaction. So one element or one part is replaced by another. So looking at this one, we got zinc and hydrogen sulfide, which is an acid. So what happens if I take an acid and I pour it onto something?
It disintegrates or something.
Well, it depends on what acid.
Most acids, you can pour them on the countertop or pour them on your skin. What does it do?
Or, well, doesn't it dissolve?
It dissolves, absolutely. There's a hint of what I'm getting at. Uh-oh. I moved down a little bit. Produces hydrogen gas. So when you pour an acid on your skin, what will it most likely do?
Burn.
It'll burn and
Rash.
hydrogen. What is hydrogen? Is it solid, liquid, or a gas, or room temperature?
It's a gas.
Gas. So if you pour an acid on your skin, specifically this acid, it will produce hydrogen gas. So it's a chemical reaction. So what happens here? If I take this acid and I pour it on zinc, the hydrogen is replaced by the zinc. So we got hydrogen gas and zinc and sulfur hanging out. One element gets replaced. You good here, Brian? Do you need some candy to get you moving? Do you need some jumping jacks?
No.
I appreciate it. I haven't seen your head down.
He's pretending.
He's pretending to
He's
be
a
one.
fraud.
Okay. Alright, what happens if two things switch to places? So what happens if B and D? Alright, so we got A. A goes to D, B goes to C. If two things switch their spots, alright, you have a double replacement. You good, Mark? Nothing that comfortable anymore, you can't just put your head on it. So we got MgO, the oxygen and the sulfur switch spots. And that's how we do it. Okay? So, what do we ask ourselves when we're doing these types of reactions? I'm going to go back here real quick. In a synthesis reaction, how many products do I have, or how many reactants do I have? Alex says this. Throw a peace sign. 2. And Alex, I can get you some candy. Did you ever get candy yet? No. So I start with 2. How many do I end with? 1. Fantastic. So when you're looking at the type of chemical reaction, if you see 2 go to 1, you know it's synthesis. Alex, help me out. How many are in a decomp? How many reactants?
It's going to be one reactant with 2 products.
Absolutely. 1 reactant, 2 products tells you it's a decomp. If it's not one of those 2, it might be one of these 2. Ready? Okay. We're going to practice this here in a moment, and I guarantee you once you get practice, like, okay, this is super smooth, super straightforward. Mr. Williams, please take me out of my misery. I'm done. Well, let's light something on fire.
Go.
This is the 5th one, and this is the last one we're going to do for today, and probably the last one we'll do for a couple weeks. All right? Is a combustion reaction. Combustion reactions. Usually, when you light something on fire, you need a hydrocarbon. Hydrocarbon, really complicated. Meaning it has hydrogen and carbon. Your body is made up of a lot of carbon and has a lot of hydrogen in it, which also explains why you are flammable. If we try hard enough, we light you on fire. But we won't do that. Instead, we're going to light other stuff on fire, like this methane. Methane, you light it on fire. What happens if you try to start a fire without oxygen?
It just doesn't go.
If you try to start a fire without oxygen, you have no chemical reaction. It can't go. It won't combust. Has to be in the presence of oxygen. And I don't care what. As long as you light a hydrocarbon on fire, it will always produce 2 products. CO2, carbon dioxide, and water. Wait, you mean to tell me if I light something on fire, it produces water? Does that sound a little funky, Lauren? Alright, have you ever been around a campfire? You guess?
I don't really remember one, but I probably.
Oh man, I'm sorry. Alright.
Should totally
Maybe.
have a campfire in here.
Alright,
and
so if I
roast
take the campfire, throw some logs in there. After a while, alright, you hear that campfire crackle, right? Where does that crackle come from?
Probably the water in the logs.
Really, really, really close. The water, alright, and the logs, absolutely, but when that water gets really, really hot, it's stuck in a pocket, and then every once in a while, it explodes and pops. So you're super, super, super close, alright? So water is being produced, but if it's trapped in the log, it explodes, and that's where you get your little crackle from. If you want to have lots of crackle, throw in a nice wet piece of wood, it'll crackle for a really long time. Throw in a dry piece of wood, thing just burns up super quick. Okay? The only thing I'm going to change for combustion types of reactions are whatever hydrocarbon you have. So this could be CH4, it could be C2H6, could be, I don't know, C10H20. Doesn't matter. Could be any of those types. You burn something, and the presence of oxygen produces carbon dioxide and water. Alright, we good here? Got the 5 reaction types? Let's do some practice. This means you get some candy, and I get to shut up for a little bit. This looks ugly, doesn't it? I thought I put that on the table. Awkward. Alright. This looks ugly, doesn't it? Well, at least I think it does. However, the first thing I want you to do is identify the type of reaction. Alright? Or can you help me out? Well, hold on. I'm just going to ask you some questions. Make sure we're, as a class, collectively doing alright. We're like a bunch of zombies right now, so I don't know if we're doing well, or we're drowning, and we just want to be done. I don't know. How many reactants do I have? 2. I've got 2 different reactants. Doesn't matter what they are. Separated by the plus sign tells me I have 2 reactants. And how many products do I have? 1. So I have 1 product. I've got my A plus my B. Put them together, and now we have the AB. All right, we take 2 things, shove them together, make 1 product. Synthesis. Yeah, what's up, John?
I was going to say synthesis.
Absolutely. Well, she mumbled it earlier. Okay, we have a synthesis reaction. We got 2 things combined together. That's half your homework. Look at the chemical reaction, predict what kind it is, and balance. Now let's get on to the balancing part. However, there's something a little different about this reaction we haven't seen before. Morgan, what's that? What's this in the chemical reaction you have not seen before? Maybe it's been a really long time. The parentheses. And what do we do with the parentheses? Alright, ready? That's what I'm going to teach it on. Alright? Scientists love to be lazy. So what do? Instead of writing the way that this molecule is written out in its true form, they love to shorthand stuff. If we were to write this molecule out in its true annotation form, it would be NH4, NH4, SO4. Alright, that would be the true full way of writing it out. You might ask yourself the question, why don't they just write N2H8?
Because that'd be a different molecule, wouldn't it?
It wouldn't be a different molecule, but by writing this in a very particular way, we can actually predict where those atoms are at. On top of that, and things we haven't quite talked about, are why does this thing like to hang out with itself? We haven't talked about those yet. So here's what I'm going to say. When it comes to the parentheses, all I want you to imagine it is multiple groupings of whatever's in there. All you need to do is multiply the numbers. So let's do this first one here. We list our elements. We got nitrogen, we got sulfur, we got oxygen, we got hydrogen. Okay, you ready? We're going to put you on the spot. Left side. Can you tell me what I have? The right side I'll do. You're going to do the left side. Ready? Why does everybody turn around and like put them on the spot? All right, let's give them stage fright. Kate, how many nitrogens do you have on the left side?
1.
Fantastic. How many sulfurs?
1.
Fantastic. How many oxygens?
4.
Fantastic. And hydrogens?
5.
Fantastic. Alright, everybody follow with me on that?
Yep.
See the 5? The 5 is the 2 plus the 3 right there and give us 5 in total. Alright? Feeling good? Okay? Alright, ready for the parentheses part? All we're going to do is multiply the numbers. Remember this tells me the groupings? So all I'm going to do is multiply the numbers. 1, times 2 times 1. What is that, Caden? 1 times 2 times 1. 2. Woohoo! Man. 1 times 2 times 4. What's 2 times 4?
8.
How many sulfurs I got?
1.
How many oxygens?
4.
4. Ready, man? I'll go for a long throw here. I knew I was going to hit the molecule. Nailed the sign.
I don't know how that's gonna work.
All right. Is everybody good here?
Yeah.
Do we see how we count the ones on the left side?
Kinda.
Kind of. All it did was multiply the numbers. If there's nothing there, what's it understood to be?
1.
Well, 1. So what's this 1 times this 2 times that 1? That guy is the 2. How do we get the 8? 1 times 2 times 4 gets us the 8. Alright, we good there? Brand new stuff. Am I balanced, Brian?
No.
No, let's do it. Ready?
Add a 1 to the nitrogen.
Add 1 to the nitrogen. Okay, I'm putting add 1 to the nitrogen.
Like the coefficient.
The coefficient, absolutely. All right, we're gonna put a 1 here now.
Want to be 2?
Absolutely. I'm just going off what you're telling me. Put a 2 here. Okay. How many nitrogens do I have now?
2.
2.
And then you would have 8 hydrogens.
Fantastic. Where would the 8 come from? We got 6 right here on the left side. Plus the 2 gets me 8.
How did you get that?
Perfectly fine.
8.
Okay. Let's do that again. Ready? You good at putting the 2 there, John?
Yeah.
The 2 nitrogens. Now let's recount hydrogens. How many hydrogens are right here?
6.
6 plus
2.
the 2 gives us 8. Cool. Usually, what I really recommend, balance everything except for oxygen and hydrogens last. Usually, those will just fall into place. By focusing on your other stuff, all right, nitrogens and sulfurs, the other stuff just kind of fell into there. If we tried to balance hydrogens first, we might have changed this number and then started running around in circles. All right? We good there, Lily? On a scale of 1 to 10, how comfortable you feel? Solid 7. Okay. We good here? Try that one out. See how you do. Ready, Brian? I'm gonna try behind the back again. That did not feel like. That did not sound like a good hit. Elena looks so peeved. She's like, I have to move now. First thing, tell me what kind of reaction it is, then balance it. Yeah, go ahead and balance it. Try to balance it. See if you get the answer I get. You know what? I won't. No. I'm just going to recount from the coefficients you gave me, Mr. Williams. Well, sure. You can just check if I got the right answer. Alright, like I said, we are going to practice these for the rest of the week. You don't need to be professional at balancing chemical reactions right now. What I'm going to say is if you don't feel comfortable with them by Friday, then it's a red flag. We got some stuff to work on. Okay. The lab I will push to next week. So we'll still do it. I promise you that. But we'll push to next week. figure out what kind of reaction it is first? No? You don't get it? You sure? You seem pretty out of it. Okay. We'll get it up. Yeah, so the parentheses you think of like multiplication. You have parentheses in math class, it means multiplication. Absolutely, that's it. And then the sulfurs is 1 times 3, which is 3, right? Oh yeah? Okay. Sulfurs are 1, absolutely. So what'd you put on the left side? Here?
Yeah.
We want 3, right? So I put what times 1 gives you 3. There you go. Follow me there? Okay. Keep going. You're almost done. John, what's up, man?
Alright, I think I might have gotten it.
Did you get 3, 2, 1, 3, 2, 1, 3?
Yep,
That's what I got.
That's what I got.
You?
I got that.
Yeah.
You're probably really close. What'd you get?
1, 2, 2, 1.
1,
Whoa.
2, 2, 1.
Funny.
Okay, we'll check it out. We'll do this in class. Alex,
Is it single replacement?
that's the first question I'm going to ask. What type of reaction is this? Single replacement. Because what's being replaced?
The iron.
Yeah, the Fe and the Cu.
Iron's coming in, kicks out the copper, and says, no, adios. Alright? Copper's now by itself. So, how does this look as far as what it looks like in our notes? Copper, sulfate is SO4, it's together, it's a unit. How do we know it's a unit? Because it shows up as the same thing over here on the right side, plus C. C comes in, kicks A out. Now we have B and C, right?
Yeah,
I guess
A.
technically it was C and B, right? Because iron goes first.
Plus
Plus A. We're good now? Cool. I'm going too slow for you. I'm going too fast. I've hit the perfect tempo for you. My 6th year of teaching, I perfected it. That's it. I'm going to retire. I'm out. Okay.
6 years.
Yep. So, what type was it, Alex?
Single replacement.
Single replacement. Absolutely. Now what we're going to do? Let's balance it. Hudson, you with us?
Yeah.
You think you can balance this one?
Sure.
What did I already do wrong?
You put the S and the O together.
Absolutely. That's the wrong thing. What I've seen some people do is they'll see S and O and they'll combine it together. Capital letters means they go by themselves. This looks a little weird now. There we go. All right, Hudson, what got on the left side?
1 iron.
1 iron.
1 whatever. What's
Copper.
Okay.
All right.
1
Sulfur and
4 oxygen.
4 oxygens. Cool. You confident on the right side?
Yeah.
All right, what do I got?
2 iron.
2 irons.
3 sulfur. Oh, Cu. Copper. 1.
Okay.
3 sulfur.
Okay.
12 oxygen.
12 oxygens. Okay. Fantastic. We're looking good, man. John, you see your movement?
Yeah.
Okay. Remember, we multiply. Anytime you see parentheses in math class, what's parentheses mean in math class?
Distribution.
Multiply, right? Or distribution, which is just a type of multiplication. Ready, Hudson?
Wait, can I get Smarty? Alright.
Okay. Now balance?
No.
No.
I can do it.
I'm trying to think of who else I've left hanging. We got tons of time, don't we? Hey, look at that. You guys are doing better in 3rd period. High
How
five.
much time do we have?
Well, 3rd period didn't even get through all the way through this question. They had lots of questions for me, so it wasn't bad, just they had a lot of questions. Alright. Elena, can you help me with that first step we worked on?
Yeah.
What's the first step we did?
You times it by 30.
Absolutely. We took our coefficient and multiplied it by 3. How many coppers do I have now on the left side? The CUs. 3. How many sulfurs? 3, okay. And then how many oxygens?
12.
Why did you multiply by 3?
Because this 3 goes with everything. So 3 times 1, 3 times 1, and then 3 times 4. So 3, 3, and 12. Follow there? Alright, we're learning. We're mastering it. We're looking good. Am I done, Elena?
No.
No. Am I close, though?
Yeah.
We are super close.
Just times out by 2.
What by 2?
Iron.
Iron, absolutely. So this becomes 2 now. Am I done?
And you times Cu by 3.
Absolutely. Whew. You good with blueberry burst?
I don't like suckers.
You don't like suckers? You like Tootsie Rolls? Dum Dum? Smarties? Smarties. Alright. When it comes to putting this in our homework, make sure you include the ones. Alright? The only person I excused that from was Katie because he wasn't here last week. He didn't know to put that ones in, but you knocked that homework out of the park, man. Alright, did you see how I regraded it? Okay. You got a 0 out of 10 because you didn't put any of your ones in. I was like freaking out on you. Okay, so make sure you put the ones in. That way schools, you know you're putting in an answer.